Welcome to Amit Thinks YouTube channel. In this video course, learn NumPy. NumPy is an open source Python library that allows you to work with multi-dimensional arrays and matrices with mathematical functions operating on these arrays. It stands for numerical Python and is written in Python and C language. NumPy allows you to perform various operations on arrays, including array slicing, joining, reshaping, sorting, intersection, etc. In this course, we have covered the following lessons with live running examples. Let us start with the first lesson. In this video, we will learn what is NumPy, its overview and the operations. NumPy is an open source Python library which is written in Python and C. Let us see the introduction. NumPy is basically used for numeric and scientific computing. It allows you to work with multi-dimensional arrays and matrices, and it also has mathematical functions that operate on these arrays. NumPy stands for numerical Python and it is faster with less LOC, that is line of code. NumPy basically allows you to perform various operations. Okay, like you want to slice an array, if you want to join two arrays or three arrays or multiple arrays, you can easily do that with NumPy. It has built-in functions for this work. If you want to reshape an array or even filter arrays, you can easily do it. Here in array slicing, you can consider that to slice an array in a range from start to end. Okay, let's say you have two or three arrays and you want to merge them, you want to join them, concatenate them, easily do it with NumPy. Also, easily break or slash an array into multiple arrays using NumPy. The concept is array split, that is to split an array. With that, reshaping an array is also possible with NumPy. Okay, so the number of elements in each dimension of an array is called the shape of an array. Now what is reshape? To reshape this dimension, that is to reshape the number of dimensions, is what we call reshaping an array. NumPy also allows filtering an array. That means if you want to fetch some elements from an existing array and create a new array out of them, you can easily do that with the filtering concept in NumPy. So guys, in this video we saw what is NumPy and what all operations you can easily perform on an array in Python with the NumPy library. Thank you for watching the video. In this video we will learn how we can easily install NumPy with PyCharm. For that, first we will install Python and pip. Pip is used to download, install and manage Python library and packages. After that we will install PyCharm. After connecting both Python and PyCharm, we will see how we can install NumPy in PyCharm itself. Since we are using PyCharm community version, free version, so we'll be working on it. Let's start. We will download and install the current Python version. At first, go to the web browser. On Google, type Python and press enter. On pressing enter, the official website is visible. Click on it, python.org. Here is the official website. Now keep the mouse cursor on downloads. Now you can see the current version Python 3.12.0 is visible. Click on it to download. It will download. It's only 25 MB. Download completed. Now right click and click on open to start installing Python. We clicked on the exe file. Minimize. Now the setup started. Here and at first select add python.exe to path. Now click customize installation. This shows what we are installing. It will install pip also. Pip is used to download, install and manage Python packages. It will also install IDLE. IDLE is an ID to run Python programs. Now click next. Advanced option, it will install Python 3.12 for all users. It will also set the environment variables. Okay. And Python will get installed in the following location under program files. Keep it a default. You can change it from here by clicking browse. But keep it as it is, no problem. Click install. Now the installation started. Guys, we have successfully installed Python. Click close. Now let us verify the installation. Go to start, type cmd. Click open to open the command prompt. Herein type the command python space -- version and press enter. This shows that we successfully installed Python. Guys, we successfully installed the current Python version. Now we will install PyCharm. For that, go to the web browser. I am using Chrome. You can use any web browser. Herein type PyCharm and press enter. On pressing enter, the PyCharm is visible. It is owned by JetBrains. Click on it. Now we have reached the official website here. Now you can directly click download here, or you can also click download. Let's click. Herein you can see PyCharm Professional is visible, which is for a 30-day trial. Then you need to pay, but we are going for the free version, that is the community. And here it is. You can download it from here. It is freely available and open source, so you can use it. Exe file download. Click on it. Now the download will begin. Here it is. The download started. It's only 418 MB. Let's wait. We have downloaded it. The exe file for PyCharm, community version, free version. Right click and click open to begin the installation. Minimize. The installation started. Click next. Now it is asking wherein PyCharm will get installed. It will get installed in the following location. Keep it as it is, and it will take 1.5 GB. Click next. Desktop shortcut, yes, we can create. Update context menu. You can add a folder to project so that you can open any folder as project. Rest keep as it is and click next. Start menu folder, yes, click install, and now the setup will begin. The desktop shortcut also got created. Now let's wait for this to complete. We have completed the PyCharm setup. I can also select run PyCharm community edition and click finish so that it begins, but I'll only click finish. So in this way we can install PyCharm. Now let us open PyCharm and connect Python with PyCharm. Can also go to start and type PyCharm instead of going for the shortcut. Here it is, community edition. Click open. Now PyCharm will open for the first time. Here in the terms are visible. I confirm. Click continue. Data sharing. PyCharm opened for the first time. You can go to customize and herein select, let's say, light theme or dark theme. I'll go for light theme, and rest keep as it is. Go to projects, click new project. Herein you can see our project will get saved here. If you want to change the name of the project, you can change from here. Let's say I'll name it Amit project. Okay. Now you need to set the environment. It will go for the virtual environment, a new environment, which is fine. The base interpreter you need to set, it is only showing Python 3.9 and 3.10. Click on the three dots. Program files, wherein we installed Python 3.12. Click on it. Select python.exe and click OK. Here it is. We have set Python 3.12 now. You can see we have set it. We have connected our Python with PyCharm. Okay. Remove this because we are creating a sample program. Click create. Okay, here is our project. I clicked here for the menus. Okay, now this is our project. This is our environment. Now we need to add a new Python file to run our first Python program. I'll right click on Amit project. Click new and herein select Python file directly. It will automatically go for .py extension. Herein add the name of your Python file and and press enter. It will create demo.py. Here it is. Now you can directly run your first project. Let's say I'll just print something. Okay, I'll go for file, save all. Right click and click run demo. Here it is. Studiopedia is visible. Okay, that means we successfully printed using the print method in Python. Here it is, Studiopedia. You can also run using run here, click run demo, or you can use Shift F10 or Alt plus Shift plus F10. Okay, you can also increase the font by going to File, Settings. Here in Appearance is visible, go for Editor and click Font. Here in the font is only 13. Let me take it to 18 and click OK. Click Apply, then OK. Now the font will increase. Here it is. Even the output font is also 18 and the editor font also. With that, you can check the location also. Here it is. See users Amit underscore PyCharm projects. See users Amit underscore, that is the username. Here it is PyCharm projects Amit project. Here is a demo.py file. With that, you can also go to the file option and click settings. Okay, and select the project and the interpreter to verify again that you have set 3.12 or not for our project, and yes, we have set the same 3.12 for our project. So guys, we successfully installed Python, pip and PyCharm. Now we need to install NumPy in it. Okay, for that you need to open PyCharm. We just ran a sample program in Python. Go to File, click on Settings. Now after clicking Settings, you need to go to your project here. Herein go to Python interpreter. Herein you can see we have pip installed, okay, which is fine, but we need to install the NumPy library. Okay, by clicking plus here, we'll be able to see all the libraries and packages available. I clicked on plus and all the packages and libraries are visible. I'll type NumPy and I'll press enter. After that, you can see our NumPy is visible. We just need to click install package here. I'll click install package. Now you can see it is installing. Here in package NumPy installed successfully. Okay. Click close. Now herein you can see package NumPy installed successfully. We have installed it. So this is how you can install a NumPy package. That's it. Now we can click OK. So in this way, guys, we can easily install NumPy library on PyCharm. In this video, we will learn how to create NumPy arrays. Okay, to create arrays in NumPy, we use the numpy.array method. We will see two ways through which we can easily create arrays in NumPy. First, by passing a tuple, and second by passing a list. Tuple and list are both collections in Python. So we will see both the ways. Okay, open PyCharm. So we will create a project. First we need to enable the menus. Go to here, then view, and here in under appearance, main menu is separate toolbar. Select it so that the menus are always visible. Here it is. It is visible now, the menus. Now we need to create a new project for our NumPy, our first project. Here it is. Let me name it NumPy. Let's say the following: NumPy create arrays, and I'll just click on create, and the location is the following. I'll click create, click new window. Okay, you can close this now. previous window, and the following is our first project. Location, you can check the following. Okay, we will check for the first time. See users, Amit underscore is the username, PyCharm projects, and here it is, and here is our project we just created. Okay, nothing is visible inside because we haven't added anything. Okay, so this was the location of all our projects. Now I'll be creating my first Python file in it because we have two examples. New, you need to directly type Python file. Let's say I'll name it demo1. It will automatically add .py because Python file is selected. I'll press enter only, that's it. Here it is. This is our first file. Similarly, create our second file because we are having two examples. Right click, Python file. I'll type demo2, that's it, and press enter. It will create a second file also. Now let us run our first program in which we'll be creating a NumPy array by passing tuple. Okay, first we need to import our library. Since we are working on NumPy, we need to import it so that we can run it. Okay, import NumPy. We need to use this NumPy again and again in our program. So I'll be giving an alias np. So I'll only write np now. That's it. Okay, now I'll be creating our array. Let's say our array name is n. Now I'll type np because I want to use the NumPy library. np.array method. That's it. Okay, since we are passing a tuple, we have used the parenthesis. Now add the elements in it. That's it. I'll add 3 elements, let's say. I'll now print it using the print command, just like in Python. Now go to File, Save All, right click, run demo1. Here it is. We have printed 1, 2, 3. This is what we wanted to print. We can also print the type by typing print bracket type bracket n. That's it. And I'll save all again. Right click, run demo1, and here it is. It is showing that this is the NumPy array. Okay, ND array is basically a shorthand name for n dimensional array. Okay, so this is how we can create an array by passing tuple. Now let us go to our demo2 program. We will create a NumPy array by passing list. Okay, let's see. Import in a similar way a NumPy as np. np is an alias. Now what I'll do, I'll create a new array using n is equal to np.array method again because we use array to create an array in NumPy. Okay, now we'll be using the brackets because we are passing a list. In demo1, what we did, we used the parentheses here. Okay, because it was a tuple collection. And in Python list, you can use the following brackets, and I'll type, let's say, elements. Go to File, Save All. Okay, we can print it, and we can also print the type using the type method. Use the type method, and within that add the array name. Now File, Save All. Right click, run demo. We created NumPy array successfully. And here it is visible. NumPy.nd array, that means the n dimensional array in NumPy. So guys, in this video we saw how we can easily create a NumPy array by passing a tuple using the array method and by passing a list using the array method. Thank you for watching the video. In this video we will learn what are dimensions in NumPy arrays. With that we will also see some examples. Let's start. So the dimensions in an array are also called the rank of an array. Okay. So an array can have 0 dimension, 1 dimension, or it can be a multi-dimensional array with 2, 3 or more number of dimensions. So to check how many dimensions an array used, we need to work around the ndim. Okay, so now we will see examples wherein we will create a 0 dimensional, 1 dimensional as well as a 2 dimensional NumPy array, and we will also check the dimensions. Let's start. So we have created a new project in PyCharm, NumPy array dimensions. Now I'll right click and create a first file. Click Python file, add the name of the Python file and press enter. So we have created our first demo1.py file. So in this we will create a 0-dimensional NumPy array and check the dimensions. Okay. First we will import NumPy as np. Herein we have created an alias np. I told you before. Now we need to create a 0-dimensional array. I'll create an array object n. With that I'll be using np, that is the NumPy alias np dot array method. And since we want a 0-dimensional array, I'll only add a single element. So this will create a 0-dimensional array, an array with no dimensions. Okay, with that I'll also print the dimensions. I told you using the numpy.endim. That's it. We missed a comma. That's it. So this will show us the dimensions, that is 0 in this case. I'll go to file and click save all. Now right click and select run demo1. Okay, so here it is. We have printed the dimensions. We can also print the array, we missed it. That's it. Right click and run demo1. Now it will also display our array. An array with a single element, that is a 0-dimensional array, dimension 0 visible. So in this way we can easily create a 0-dimensional NumPy array and check the dimensions. Now let us see the other examples. For that we will create new files. So for the second example, we will be creating a 1-dimensional NumPy array and check the dimensions. Okay, for that import NumPy and also create an alias. Now I'll create our array object n, and using NumPy, that is the alias np, I'll be using the array method, and within that I'll be creating a 1-dimensional array. Let's say I'll add 3 elements. So I've created an array by passing a list. Okay, so here it is, our 1-dimensional array. Now I'll print the array, print method, and add the object name. Now I'll display the dimensions using the numpy.endim. That's it. Here it is. We have created our 1-dimensional array. Now let us print it. File, save all. Right click and run demo2. Here it is. We printed our array. That is the array elements, and the dimensions are only 1. Now in this way we can easily create and check the dimensions for a 1-dimensional array. Go to demo3. Now we will create a 2-dimensional array. For that import NumPy as np. We have imported our library and used an alias np. Now use n is equal to dot numpy dot array method, and within that we will create a 2-dimensional array. Okay, so for 2 dimensions, here it is. Okay, so we have created a 2-dimensional array. Now herein add the elements. 2-dimensional array, you can compare it with a matrix. So we created an array with 2 rows and 3 columns. Here it is. Print. That's it. And also print the dimensions using the endim. N.endim. That's it. Go to file, click save all, and that's it. Right click and run demo3. So we have created our array. I told you it will be a 2-row 3-column array, and the dimensions are 2 because it is a 2-dimensional array. So this is how you can create a 2-dimensional array. So this is how, guys, we can easily work around dimensions in NumPy. Thank you for watching the video. In this video, we will learn how to initialize NumPy arrays. So you can initialize NumPy arrays using the NumPy.zeros method. This will allow you to initialize the arrays with zeros. Okay, so we will see two examples and initialize NumPy arrays. These two examples will have different dimensions and will get initialized by 0 using the NumPy.zeros method. So every element in the array will be having element 0. Let's see two examples. So here we have our PyCharm ID. We created a new project and gave it a name. Let us create two files. Right click new Python file. I'm naming it demo1. I'll press enter and it will add a .py extension because Python file is by default selected. Here it is. Now we'll create second file demo2.py. So now we will easily initialize NumPy array with zeros. For that, first we'll be importing our library. Import NumPy and creating an alias np. Now create an array object n and use NumPy, that is the alias np dot the zeros method to initialize an array with zeros. Let's say we have two elements. Now I'll print it. This is how you can print using the print method, and I'll also print a type, let's say. Okay, so I'll just go to file and click save all, right click, run demo1. So here it is, we have initialized our array with zeros, 2 rows 3 column array. Okay, 2 rows and 3 columns, and we initialized it with 0. So this was a multi-dimensional array, that is a 2-dimensional array in the form of a matrix. Now let me go to the second example and I'll initialize. First I'll import and add an alias also. Now I'll see another example using NumPy.zeros and I'll be initializing elements with 0 for a 4x4 array, 4 rows and 4 columns. Let me print it and the type also. That's it. We have printed it and this is 0. File save all, right click and run demo2. Here it is, we created a 4-dimensional 4x4 array and we printed it. We initialized every element with 0 and we also printed a type, that is the nd array, the n-dimensional array. So guys, in this video we saw how we can easily initialize NumPy arrays. Thank you for watching the video. In this video we will learn about the data types in NumPy. Consider data types as a collection or categorization of data items. For example, we can have string data types, integer data types, boolean data types and others. In NumPy, the following are the data types. We have b for boolean, u for unsigned integer, f for float, and others are also visible, like for string we use s. So in this video we'll be discussing the following examples where we will create simple arrays and we'll try to get the data type of it so that we can understand that which are int and which are string types as per our examples. With that, we'll also try to set the data type size with the d type parameter, let's say for a string type. We'll also see how we can convert one data type to another using the as type method. So let's see. At first we will get the data type of a NumPy array with integers. So we'll be creating an integer array and we'll print its data type. Let's see. So we have created a new project in PyCharm. So let me create a file quickly. Press enter. And this will create a first Python file. In this example, we will create a NumPy array with integers and will display its data type. For that, import NumPy library as np. This is an alias. Now let us create an array object n is equal to NumPy dot array method to create an array. Simply, we saw this before also. Add some values. Let's say we added 3 values. Okay, and just print the data type using the dtype property. That's it. Go to file, save all, right click and run it. So here it is. Int32 is the type for our array with integers. Okay, in this way we'll also work around the second example. In the second example, we'll be getting the data type of a NumPy array with strings now. So for that, we'll be using the same dtype property. Okay, so this is our PyCharm ID. We'll be getting the data type of a NumPy array with strings. Import. We added an alias np. Create a new array object. Create an array. Let's say we added string values. Okay, we added 5 values, 5 string values. That's it. Just print the type and let's see what is visible. Using dtype, file, save all, right click, run demo 2. Sorry, arrays. No problem, right click. So the following is visible. That means Unicode string is visible here. And the following type is visible. Now let us see another example. Now we will set the data type size using the dtype attribute within a NumPy array. Okay. What we'll do, we will set the data type as string and set the size to 5. Okay, let's see. Import NumPy, add an alias np. Now use the array object, add an array. Let me print something. So herein we printed 5. Here we created an array of strings with the 5 values. Okay. Now I'll be using the dtype to set the type. I'll be setting the s5 type, that is for strings, and I'll be printing it. I'll be printing the data type now, n.dtype attribute, file, save all, right click and run it, run demo 3. Let's see what is visible. Okay, the following is visible, that is the type. So herein we set the data type string with the value 5. So it is s5 visible here. S means for string and 5 means for the size. Okay, and we printed the data type after that. Now let us see a last example in which we'll convert one data type to another in NumPy. We'll be using the as type method. What this method will do, this will create a copy of an array and then set the new data type. Simple. This is how using the as type method we can convert one data type to another. We'll see an example. Okay, let us see the example. We will be converting one type to another. Import NumPy as np. Np is an alias. For our NumPy library, create an array object is equal to NumPy.array method to create a new array. Let me add some values. Okay, we added 5 integer values. Now I'll print it. Now I'll also print that data type using the dtype attribute. Now what I'll do, I'll just save all, and I'll just right click and print so that we know what we are doing till now. This is what we printed. Okay. Now what I'll do, I'll create a new object, array object, and I'll use the as type method with the previous array, that is n.asType, and within that I'll be adding the new data type to which I want to convert, that is from u to here to my integer, that is int32. For that I use the as type method. Now I'll print it. I'll also print the type using dtype attribute. That's it, so that it's easier for us to understand. File, save all, right click, run demo 4. So now you can see we printed our first array and displayed the data type. Then we converted this u2 to int32 using the as type method. Okay, here it is. So guys, in this video we saw how we can easily work around data types in NumPy. We displayed the data types, we also added a data type using dtype attribute, and we also converted one data type to another using the following as type method. In this video we will learn how we can understand the array indexing concept in NumPy. So through array indexing you can easily access array elements. We will see some examples also to understand the concept. Let us begin. So array indexing basically includes accessing array elements. So if you are creating 0-dimensional, 1-dimensional, 2 or 3-dimensional arrays, you can easily perform indexing, that is access the array elements. Like any other programming language, the 0th index is element 1, the first index is element 2, and the flow goes on in an array, and the same applies here. You can access array elements using the index number. Let's say you want the first element, go for the 0 index. For the second element, you need to use the first index. In this way the flow goes on. So in this lesson we will cover all the major arrays, like we will learn how to access elements from a 1D, 2D or a 3D array, and an important concept, how to access elements from the last with negative indexing. First we will begin with accessing elements from a 1D array. Herein we have two examples for accessing elements from a 1D array. First we will access the first element, and then we will access the fourth element. For the first element you need to use the index 0. For let's say the fourth element, you need to use the index 3. So let us first see these two examples. We have created a project on PyCharm. Right click, new, create your first file, demo1. When I'll press enter, it will automatically add the .py extension because Python file is by default selected. Here is our first program. I'll create the second one also, demo2. Now we have our two programs. So here we will access the first element from a 1D array. For that import NumPy, create an alias also, np, create a new array. So I have created an array object, n is equal to numpy.array. Using the array method, we will create an array. Now print the array directly, and to print the first element, type n and the index number. That's it, 0. I told you for the first element we need only 0th index. Now I'll go to file, save all, right click and run demo1. Here it is. We have printed our array, and the first element we printed, that is 10, using the first element, that is index 0. Now let us see the second example. In the second example we will access the fourth element, that is index, it should be -1, that is index 3rd. Let us import NumPy again. And let's say I'll take the same example. And I need to access the fourth element, that is 40 I need to access. For that I'll use index 3. In place of 0 mention 3, that's it. File, save all, right click, run demo 2. And here it is, we have printed our array and we have printed the 40, that is the fourth element, 0, 1, 2, 3 using the third index. So guys, we saw how we can access elements from a one-dimensional array using the first two examples. Now we will see how to access elements from a two-dimensional array. So the concept is different. Obviously, two-dimensional array works like a matrix. So here it is. If you want to get the first element of the first dimension, use 0, 0. In the same way, if you want the, let's say we have a 3 by 3 matrix, for the last element, you need to use the following indexes 2, 2, that is row column. That means row 3, column 3. This also works like an index to access elements, that is -1. If you want the first element of the dimension 2, you need to mention 1, 0. That is second row and first column. So let us see two examples to understand the concept. So here is our third example. Right click Python file, demo 3. Let us also create the fourth example, demo 4. These two examples for a 2D array. So let's see, we will access the first dimension elements from a 2D array. For that, let me import NumPy. And I'll create a 2D array. N is equal to numpy.array. Herein N is our array object. Within add for the first row, and this is for the second row. This creates a two-dimensional array. Now I'll just print the first dimension elements. First I'll print the array, then I'll print the first dimension elements. I told you in the example before, 0, 0 will print the first element. Similarly goes for the other, 0, 1, 0, 2, okay. Now I'll go to file. Now I'll go to file, save all, right click, run demo 3. So herein we have printed our matrix, 2 rows and 3 columns, that is 2 by 3. And we were printing the first dimensions. That means we were printing the following. Okay. For that, what we used the following indexes. 0, 0 is the following, 0, 1 is the following, 0, 2 is the following. It printed it. So in this way, guys, we can print the first dimension elements from a 2D array. Now let us see the fourth example. Herein we will access the second dimension elements from a 2D array. Let me import NumPy. And I'll take the example from here. Now print the second dimension elements. That means 1, 0, 1, 1 and 1, 2. So this will print the second dimensions. Right click, run. Now in the previous example we printed the following. Now we printed this. That's it. We used 1, 0. That means this was 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. And we printed all three, 4, 8, 12. Okay. So in this way, guys, we can work around a 2D array and access elements. So guys, we saw how we can access elements from a two-dimensional array using the third and fourth example. Now let us see how we can access elements from a three-dimensional array using the fifth and sixth example. Let's see. Let me create 5th and 6th. Access elements from a 3D array. This is our first example for the 3-dimensional array. Let me import NumPy as NP. NP is an alias for our library. Let me create a 3D array. Herein we printed our 3D array. So 3D array consists of 2D arrays. So the first 2D array is the following and the second one is the following. For our 3D array, print it. Now let me access some elements out of it using the index numbers. So for the first element we printed the following. For the second element we printed this, and for the third we printed the following. So what this will do, always in a 3-dimensional array, the first one is which 2-dimensional array you are accessing. We are accessing the first one, that is 0th index. 0, 0, 0, 1 and 0, 2 will get printed. That means 5, 10, 15. You can relate this with 2-dimensional. Run demo 5. Here you can see first we printed our 3-dimensional array. Here it is with two 2-dimensional arrays, I told you. And from the first one we printed the first. We printed 5, 10, 15. Here it is. So in this way guys, you can work around. Let us see the second example. Here it is. Import NumPy as NP. Now take the same example. So in the previous example we printed from here. Now we will print from here. How? For the same syntax. First we will add 1 here, that's it, and the same concept will work. Now from the following array, because we have set 1, if we set 0, the first one will get accessed, but we have set 1, so here, and the row and column values are visible, column 1, column 2. So row 0, column 0, that is following first, then row 0, column 1, here it is, row 0, column 2, here it is, 45. So 35, 40, 45 will get printed. File save all. 35, 40, 45 run. 35, 40, 45 got printed from our 3D array. That is the following. We printed the following. Now we have printed this. So guys, we saw how we can access elements from a 3D array. Now the last concept, in which we will access elements from the last with negative indexing. Herein we will see two examples. We will access the last element from a 1D array, and we will then access the last element from a 2D array using the negative indexing concept. Let's see. Let me create two files. Here we will access the last element from a 1D array with negative indexing. For that, import NumPy first and create a 1D array. N is equal to numpy.array. That means n is our array object, and we are using the array method. Within that, create your 1D array. I'll add let's say 3 elements in my 1D array, and I'll print the last element using -1, that is negative indexing. You can print here last element. Okay, You can also print the value of array. That's it. File, save all. Right click and run demo 7. Here it is. 5, 10, 15 was our array, 1D array, and we printed the last array using -1, 15. Okay, now demo8.py. Now let us see how we can access the last element from a 2D array with negative indexing. Import NumPy as np. Then create a 2-dimensional array. N is equal to numpy.array, that is np.array. Now create your 2D array. 1, 3, 5 and 4, 8, 12 for our matrix, that is 2D array. That's it. Print. Now I'll print the last element. How? Using n0, -1. This will print the last element. This will print the last element. Okay. File, save all. Right click, run demo 8. Let's see what is the result. It printed the last element from the first row. If you want to print the last element from the second row, for that what you will do, you will add 1 here because this was the first row and this is the second row. Let's see, right click, run demo 8, and here it is. We printed the last element of the second row also, that is 12th. I told you the first row and the second row by this concept. File, save all, and this will look good. This looks fine. So in this way guys, we can access the element from an array using the negative indexing. In this video we saw how we can easily work around the indexing concept in NumPy. We saw some examples also. In this video we will learn how we can easily slice an array in NumPy. With that we will also see some examples. So array slicing basically means to slice an array in a range from start to end. Okay, here we have shown, let's say you want elements from index 1 to 3. For that you need to mention the range, that is 1:3. That's it. The syntax is here. That means from start to end, that is the start index in the range is the first one and the end is the last one. But you need to remember the end index is excluded. Okay, it includes the start index but excludes the end index. Okay, so this is how you can work around slicing in NumPy arrays. So we will see the following 4 examples to understand the slicing concept. Okay, in which we will see how to slice index between a range. With that we will also see how to slice from one index till the end of the array, and also from beginning to any middle index. Okay, so we will see all these concepts to understand the slicing in NumPy. So we have created this project in PyCharm, NumPy array slice. So right click, click new and click Python file to create a new Python file. Let me name it, it's demo. Press enter and it will automatically add the py extension because Python file is by default selected. So I pressed enter and here is our first file, demo1.py. So at first we will see how we can slice from index 1 to 3. 3 is excluded. For that import NumPy. We also created an alias np. Now create a new array object. We have created n. So here n is equal to NumPy, that is np.array. And within that add array elements. So let's say we added 10 array elements. Now let us slice and print it. So within the print method, I'll type the array name and now I'll set the range. So this will print from 1 to 3, but it will exclude the third index. That's it. Go to file, save all, right click, run demo 1. Here it is. It printed 25. That is, it was from 1 to 3, that is 25, 30, 35, but excluding 3. So that means only 25 and 30. Okay, so now let us see the second example. In this we will slice from 2 to 5 excluding 5. That's it. You can import NumPy. Okay, I'll just copy this. That's it, because we are taking a similar example to understand. Before that we went from 1 to 3. Now I'll go for 2 to 5. It will exclude the fifth element. 0, 1, 2. From 2 to 5, 3, 4, 5. This will get selected, but since the last index is excluded, only 30, 35, 40 will be the result. Right click, run. Here it is, 30, 35, 40 is the result. Okay guys, now let us go to the third example. Demo 3. In this, we will slice from index 5 to last. Okay. For that, NumPy, now let us take the code from here so that we can relate. Here is our array with 10 elements. Now what we need to do, from index 5th to last. Now we will use the colon, 5th, 5 colon. So this will print from 5 to last on its own. Right click, run demo 3. Here it is, from 5 to last, 0, 1, 2, 3, 4, 5. From 5 to last, and the last will also get included because we have used colon, not the end range. So this is how we can print from index 5 to last. Now let us see the next example. Right click, Python file, demo 4. Here it is. We will slice from beginning to index 5. Now import NumPy as np to import the NumPy library. Now we have our new array using the array method with 10 elements. Okay. Now what we will do, we will just remove the colon and add it here because we want from beginning to 5th. This will exclude the 5th index. Let's see, right click, run demo 4. And herein you can see 0, 1, 2, 3, 4, 5. We wanted to select from the start to 5th, but excluding 5th. So when you will add the colon before, it will exclude the index you are mentioning. So in this way guys, we can easily slice arrays in NumPy. So we saw the following 4 examples to slice an array. Now let us see how we can slice a one-dimensional array with step. So you can also mention step with the slicing concept. Slice step means to jump elements. If you will mention the step as 2, it will jump 2 values. And here is the syntax. We were having start and end for the syntax. Now we have the step also. Now let us see an example. Now we will slice 1D array with step in NumPy. Import NumPy as np. Let us add the elements using the array method. So we added 12 elements, let's say. Now I'll slice this 1D array with step 1 colon 10 colon 2. This is what we added. So the 2 here is the step, and this is the start and end range. 1 colon 10 means from first index from the following till the 10th index. Okay, and within that it will jump to, because we mentioned step as 2, run demo 5. Here it is. It will begin from the first and it will jump from 10 to 20, 20 to 30, 30 to 40 and 40 to 50. This is what we wanted to show, the role of step. So guys, now we will see how we can slice 2D dimensional arrays. We will see two examples. We will slice from index 2 to 5 and exclude the fifth index, and we will also slice for both the dimensions because we are having two-dimensional arrays here. Let's see the example. Now we will slice a 2D array from index 2 to 5 and it will exclude the fifth index. Import NumPy. Now create a two-dimensional array using the numpy.array, that is np.array. Okay, here it is. We have created a two-dimensional array. Now I'll use the print method and within that I'll slice the above 2D array from index 2 to 5. 0, 2, 5. So what I did here, 0 here means the first one in a 2D array. If I would have added 1, it would have selected the following. Simple. Now from the first one, select 2 to 5 and exclude 5. That means 0, 1, 2, 3, 4, 5. This should be selected, but it will exclude the fifth value. Therefore only 50, 70, 90 will get printed. Save all, right click, run demo 6. Here it is, it printed only 50, 70, 90. Now let us see another example. Right click, new Python file. Now we will slice for both the dimensions. Let's see. Import NumPy as np. Create an array. N is equal to NumPy, that is np.array. Within that mention your 2D array. Here it is. Now print. We will print from 2 to 5 excluding 5. Right click, run. So herein you can see 0, 1, 2, 3, 4, 5. Exclude 5 and add 50, 70, 90 here, and the same goes for the following 12, 14, 16 here. So in this way guys, we can easily slice both the dimensions. So guys, in this video we saw how we can easily work around array slicing. Thank you for watching the video. In this video we will learn what is an array shape in NumPy and how we can find the shape of an array. We will see 4 examples. Let's start. So basically, shape is the number of elements in each dimension of an array. To find the shape, we use the shape attribute in NumPy. That's it. So to understand the concept in a better way, we have 4 examples. We'll be creating a 0-dimensional, 1-dimensional, 2-dimensional and 3-dimensional NumPy array and find their shapes individually. So let's start with the examples. So herein we have created a PyCharm project. Within that we will add a file. Right click, new Python file, so that we can create a program. Click on it. The first file will be creating demo1.py. The extension will get added on its own because Python file is by default selected. Just press enter. Now we have 3 more programs. So I'll create demo 2, 3 and 4 also. So let's begin the first program. At first we will import NumPy. Let us first create an array. N is equal to NumPy, that is np dot array method, and within that, since we are creating a zero dimensional array, we will only add a single value. This is a zero dimensional array. Now let us print the array shape and dimension also. So here we have printed the array, the dimension as well as the shape using the shape attribute. File, save all, right click and run demo 1. Okay, sorry, ndim. Now it's fine. File, save all, right click and run it again, run demo 1, and here it is. First the array got printed, only one element. The dimension is 0 because it's a zero dimensional array, and the shape is the following for a zero dimensional array. That's it, we printed it. Now let us move to the second program, within which we'll be finding the shape of a one-dimensional NumPy array. For that, first import NumPy and create an alias. We are creating np as an alias. Okay, then create the one-dimensional array. N is equal to numpy.array, that is np.array, and in bracket create your one-dimensional array. So this is how we created. We added only 3 elements, let's say, in our one-dimensional array. Now I'll print the array, then I'll print the dimension using ndim attribute, then I'll print the shape, n.shape, using the shape attribute. That's it. So here it is. Now go to file, save all, right click, run demo 2. So here it is, guys. For our array, we printed the array. After that, we printed the dimensions. This is the one-dimensional array I told you, and the shape. So one-dimensional array will display the shape like this. 3 is the number of elements in it. Let's say I added one more, and I'll right click and run demo 2. It will display 4. For that means the number of elements. So I'll do it again, right click, run demo 2, it will display 3. So this is how a shape gets displayed when we have a one-dimensional array. So this is how we can work around one-dimensional array and find the shape of it in NumPy. Let me go to the third program. Here it is. Check the shape of a two-dimensional array. That is a matrix. So first import NumPy. Create an alias np. Now create an array. NumPy, that is np.array, and create a two-dimensional array. So for the first row we have 1, 3, 5 elements, and for the second row we are adding, let's say, 4, 8, 12. So here we have a 2 by 3, that is 2 rows 3 column matrix array, you can say. Now print the array, display the dimension, display the shape, file, save all, right click, run demo 3. Here it is, guys. First our array got displayed, 2 by 3 matrix. Dimension is 2 and shape is 2 by 3. I told you this is a 2 by 3 matrix. So shape is 2, 3. In this way we can find the shape of a 2D array. Now let us see how we can find the shape how we can check the shape of a three-dimensional NumPy array. So here in import NumPy, create a new array object n is equal to numpy.array, and within this we will add a three-dimensional array. So here is our three-dimensional array. Okay. Now let us print the array. Then we will print the dimension using numpy.ndim attribute, and then we will print the shape using shape attribute. That's it. Go to file, save all, right click, run demo 4. Here it is. So first we have printed our three-dimensional array. So this is our three-dimensional array above. That's why the dimensions are 3. And here it is displaying the shape. The last two displays that we have 2 rows, 3 columns in our arrays. Here it is 2 rows and 3 columns. Okay, so the first number displays the number of 2D arrays. So we have two 2D arrays here. The first one is the following, second one is the following, and the rest two number displays the row and column index for each array. So here we have 2 rows and 3 columns, that is 2 rows first and second, and 3 columns, okay, for both our 2D arrays. So this is how we print our three-dimensional array, and the shape is also visible, we have shown. So guys, in this video we saw how we can work around NumPy array shape. We also saw what is a shape and how we can find it for 0, 1, 2 and 3 dimensional array. Thank you for watching the video. In this video we will learn how we can easily reshape a NumPy array and what does reshaping an array means in NumPy. With that we will also understand that what is the need of reshaping an array. We will also see some examples. To understand reshape, we should understand shape. The number of elements in each dimension of an array is called the shape. So if you want to reshape the actual array, okay, that is to reshape the number of dimensions in an array, you need to use the numpy.reshape method. Now let us see why we want reshape. So it allows you to edit the number of elements in a dimension, obviously, because we are changing the dimensions itself. With reshape, we can also add or remove dimensions. Okay, that is, we can also flatten the array, like from 3D array to 1D array, or we can also reshape from 1D to 2D array. So these both examples we will focus in this video so that we can understand the reshape concept completely. We will reshape dimensions from 1D to 2D, and we will flatten the array, that is from 3D array to 1D array. So let's see. So guys, we have our PyCharm project here. We created a new project for reshape examples. Right click, new Python file, create a new Python file, demo1. I'll press enter. It will add the .py extension on its own because Python file is by default selected. Press enter. So here we will see our first program, and let us quickly create our file for the second program also, demo2. That's it. Let us see the first example, reshape dimensions from 1D to 2D array in NumPy using the reshape method. For that, let us import NumPy since we already installed it. Create an alias np. Now let us first create a 1D array so that we can reshape it. Create a new array object, n is equal to NumPy, that is np.array, and create your 1D array. Let's say I'll add 6 elements. Let us print the array. Now let us reshape, create a new variable, for the output. So this will now have a 2D array because we will reshape. Enter the array you want to reshape, that is the array name, object n dot, mention the reshape method. That's it, and within that mention the dimensions you want. This is a 1D array, we wanted the following 2D dimensions, that is 2 row 3 column matrix from this 1D array. That's it. Reshaped array, that is, it is now a 2-dimensional array, that is RESARR will be having a 2-dimensional array. File, save all, right click, run demo 1. Here it is guys, we were having the following 1-dimensional array with 6 elements. The reshape method converted it to a 2-dimensional array, and it was having 2 row 3 columns because we have set it in the reshape method, 2 rows and 3 columns. Okay, you can check, we displayed it. In this way we can reshape a 1D array to a 2D array. Now let us see the second example in which we will flatten the array, that is convert a 3D array to 1D array using the reshape method. This is also known as flattening the array. First import NumPy as NP. NP is an alias. Create your array. We are creating a new array n. Mention NumPy, that is NP, that is np.array, and within that create your 3D array because you want to convert it to our 1D array. So here it is guys, our 3D array. This is having two 2D arrays, one the following and the second one is here, with 2 row and 3 columns for each 2D array. Let us print our 3D array, that is 3-dimensional. And use RESARR, that is a new variable you can say, or a new array because we are reshaping it. Use the last array, that is n dot reshape method, and mention -1. What this will do? This will convert our 3D array to 1D array. Let us print the reshaped array. Okay, and mention the variable, the array, a new array that will be returned. File, save all, right click, run demo 2. Now herein you can see we were having a 3D array, okay, and we converted it to 1D array. Here it is. Now it is having all these elements, 12 elements is now in our 1D array. So guys, we saw how to convert a 3D array to 1D array. In this video we saw how we can easily reshape an array in NumPy. We also saw that why reshape is required, and we worked around 2 examples wherein we reshaped from 1D to 2D and also flattened an array from 3D array to 1D array. Thank you for watching the video. In this video we will learn how to iterate NumPy arrays. So iteration means displaying each and element of an array. So we will be using loops. We will also see some examples. Iteration means displaying each and element of an array. For that we will be using for in loop. Okay, we will work around some examples to iterate a 1D array, 2D array as well as a 3D array. Let's see the examples. So here we have our PyCharm project. We have created a new project. Let us create a new Python file. Right click, new Python file. Let us name the file. I'll only add the name, and after pressing enter it will automatically add the .py extension because Python file is by default selected. Here it is, demo1.py. Now let me create 2 more files because we are having 3 examples. Let us begin with the first example. First import NumPy and create an alias, that is np here. Now let us create a 1D array. N is equal to, n is our array object, you can say. N is equal to numpy.array, that is np.array. Within that create a 1D array. Herein we created an array with the integer array with 6 elements. Now we can iterate the array. Okay, for that I'll be using the for in loop, that is for a in n. N is our array, this the following. Now when we'll print the value of a, it will display each and every element one by one. With that we can also display the, for that we can also display the type of the array by type bracket the array name, and similarly we can display the data type also. Okay, using n.dtype property, and let's say I'll display the dimensions also using the n.ndim property. That's it. Go to file. That's it. Go to file, save all, right click, run demo1. So here it is, guys. We have iterated the array. Okay, this wasn't needed. Then we have printed the type. Look, we have iterated one by one. Iteration means displaying one by one. Iterating means to iterate one by one. Then we have shown the type. The following is a type, that is n-dimensional array, nd array. Data type, here it is, int32, that is an integer array, and dimension 1 because it was a one-dimensional array. Here it is, one-dimensional array. So in this way we can work around one-dimensional array and iterate it using the for in loop. Let's go to the second example, in which we will iterate a two-dimensional array. For that, first import NumPy as np, then create the two-dimensional array. Create a two-dimensional array, n is equal to np.array. Now create a two-dimensional array. So here we are creating a 3-row 2-column array, 3 by 2. So I hope you know two-dimensional means a matrix. So we created it. Now let us iterate it, that is print each and every element using the for in loop, for a in n, and print the value of a. This will print this will print our array colon. So using the for in loop we have printed our array. We can also print the type. Then we can print the data type, dtype property, and we will also print the dimensions by using the n.ndim, that is ndim property. That's it. Go to file, save all, right click and run demo2. Now here we printed our two-dimensional array, that is a 2D array, which is 3 rows and 2 columns, and the type we printed using the type method, the following, that is nd array, n-dimensional array, Then we printed a data type, that is integer array int32, and dimensions. This is a two-dimensional array I told you. So using ndim, it printed 2. Okay, so in this way we iterated a two-dimensional array and got some other information also. We iterated using the for in loop. Now let us see our third example wherein we will iterate a three-dimensional array. Let us first import NumPy as NP. In a three-dimensional array, the 2D matrices in the three-dimensional array will get iterated one by one for the complete 3D array iteration. Let's see. Let us create a 3D array. N is equal to NumPy, means the alias np.array. This looks fine. So here in our 3D array, we created two 2D matrices. That is, first one is the following and the second one is here. Okay. Now we will print the iterations. Let's say iterating. Now what will happen? We will use the for in loop for a in n, that is our array name, and within that, since we are printing the 2D matrices, that is the 2D matrices are iterated one by one. So herein we will add each matrix so that they get printed one by one. Obviously 3D dimensional array is having two-dimensional arrays. So we printed just for the sake of showing. So here it is, it will iterate one by one. First it will print the following, and after that it will print the second array. Let me print the type and other stuff also. I can take from here. We printed the type using the type method and added the array name in it. Then we printed a data type using the dtype property, and then the dimensions using the ndim property. That's it. Go to file, save all, right click, run demo 3. Now here it is. First it printed our complete 3D array. How? By iterating the 2D matrices one by one. The first one I told you, it will get print first, then the second one will get printed. Here it is. The first one got printed first, the following, and the second one got printed after that. And we added a text also so that it's easier for us to understand. Then came the type and data type and dimensions. Type, nd array means n dimensional array. Type, data type means int32, and ndim means dimension 3. That is a 3-dimensional array. This is what I told you. So through this we can easily iterate a 3D array using the for in loop. So guys, in this video we saw how we can iterate arrays in NumPy using for in loop. Thank you for watching the video. In this video we will learn how to easily join NumPy arrays. For that we'll be using the two methods, that is concatenate and stack. Let's see them one by one with examples. To join two or more arrays in a single new array is what we call joining. So we can easily join two or more arrays in NumPy into a single array. Okay, for that we have these two methods, concatenate as well as stack methods. So to join in SQL we use keys. Okay, but in case of NumPy we use the following two methods. Within stack we have 5 more methods: stack, hstack, vstack, dstack, and column stack. We will see them all one by one, but at first we'll be beginning with joining using concatenate method. Let's start. So we will directly understand using an example, that is how to join arrays with the concatenate method. Let us begin. Here we have our PyCharm ID. We have created a new project for our examples. So I'll right click, click new, and click on Python file to create my first Python file. Type the name demo1. When I'll press enter, it will automatically add the .py extension because Python file is by default selected. Here it is. So guys, first we will join NumPy arrays using the concatenate method. Let us import NumPy first using import NumPy as np. We have imported NumPy and also created an alias so that we don't need to write NumPy again and again. Now we will create two arrays. Let us create the first array object. N1 is equal to NumPy, that is np.array, and within that we will add some elements. We added 4 elements. Now create the second array, numpy.array. Add elements. Let's say I added 4 elements again. Now let us iterate. For iterating, we are using the for in loop. For a in n1, now print a and it will print the entire array. Do the same for the second array. N2, this will print the second array. Now let us join using the concatenate method. For that I will be creating a new array, that is this is the output array, because obviously both of these arrays will get joined in a new array. Type np dot, that is numpy dot concatenate, and within that mention both the arrays you want to join. That's it. Here and display the array. That's it. This will print the array after joining. Go to file, save all, right click and run demo1. Now here is the output. First it printed both the arrays here, first and second. After that it joined it. You can see here is the first array and here is the second array. It joined both of them successfully. So guys, we saw how we can easily join arrays using the concatenate method. We joined two arrays. Now let us see how we can join NumPy arrays using the stack methods. The following are the methods through which we can easily join arrays. Let us see them one by one, beginning with the stack method. With this function we can easily concatenate arrays but along a new axis. So we will pass a sequence of arrays we want to join to the stack method along the axis, but if you won't mention the axis, it will be considered as 0. So let's see. Now we will join NumPy arrays using the stack method, that is the following. The first stack method, that is stack only. For that import NumPy as np. Now we need to create two new arrays and display them. For that we can go to the first example and copy the same arrays. Here it is. We created two arrays and printed it. Here it is. Now guys, what we need to do, we need to join them using the stack method. For that create a new array, that is the output array resarr, and within NumPy, that is np.stack. Add both n1 comma n2. So herein we won't mention x's, so it will by default considered as x's is equal to 0. Now we will print the result after joining. File, save all. This is fine now. Okay, file, save all. Right click and run demo2. So herein you can see after joining, since the axis was by default 0, it displayed the output in a new array. This is 2 by 4 matrix. Okay, because it was axis is equal to 0 here by default, but what if I'll type axis is equal to 1? right click and run demo 2, it will display the opposite, that is 4 by 2 array. So in this way guys, you can easily work around numpy.stack method. Okay. Now guys, we will see the hstack method to join numpy arrays. This will stack along rows. So let us see an example. So now we will join arrays using the stack method, that is hstack. For that, import numpy as np. Np is an alias. Now let us create two arrays. I'll copy from here and I'll also display it. Here it is. Now guys, we need to just concatenate using hstack. For that, create a new output array, resarr. Use numpy.hstack. Within that, we entered both the arrays we want to join. That's it. We need to print it. After joining along rows, that is hstack. Now that's it. Go to File, Save All, right click and run demo 3. This will stack along rows. After joining, here it is. Array 1, array 2, and after joining, it stacked along rows. Now guys, we will see how we can stack along columns using the vstack method. Let us see an example. So guys, now we will join NumPy arrays using the vstack method. This will stack along columns. For that, import NumPy and create an alias. Now let us create two arrays. I'll copy directly from here to save time. So here we created two arrays, n1 n2, and displayed them one by one. And now we need to join the arrays. For that, type resarr is equal to np dot, that is numpy dot vstack, and within that mention both the arrays you want to join. What is this? This is the output array we created. The output will be displayed in this array. So we will just print this array. After joining along columns, okay. Go to File, Save All, right click and run demo 4. This is the first array and this is the second array. Now after joining along columns, the following array is visible. That is the vstack method. Okay. Now we will see how to stack along depth. Depth means height, that is to stack along depth. We use the dstack method in NumPy. Let us see an example. Here it is guys, now we will join NumPy arrays using the hstack method. For that, import NumPy and create an alias. Let us copy both the arrays from here. Array 1, array 2, and we displayed them. We will create a new array for the output resarr, and within that we will use the dstack method, numpy.dstack, and within that mention both the arrays we want to join along depth, that is stack along depth. Now the output is in resarr, so we will print it. resarr. Okay. Now I'll go to File, Save All, right click and run demo 5. Now here it is, the first array, the second array, and after joining using the hstack method, it will stack along depth as shown here. Now we will see the last example, that is how to stack according to columns using the column underscore stack method in NumPy. Let us see an example. So now we will join NumPy arrays using the column stack method that will stack according to columns. So for that, first import NumPy and create an alias. Now create two arrays and print them. We are taking from here. Here it is, two NumPy arrays, and we printed them. That is, I iterated them. Now I'll use RESARR, a new output array. The output will get saved here. We will use numpy.column underscore stack method to join. Type the arrays you want to join, that's it. And within that, print. After joining, here and mention RESARR, that's it. Go to File, Save All, right click and run demo 6. Now here it is, iterating array 1, then we iterated array 2, and after that we stacked according to columns using the column underscore stack method. Okay. So in this way, guys, we can easily work around joining NumPy arrays using the concatenate and stack methods. Thank you for watching the video. In this video, we will learn how to split a NumPy array. To split means to break or slash an array into multiple arrays. For that, we'll be using the array underscore split method, and we will also work around some examples. Let's see. Split means we can easily break an array into multiple arrays. Let's say you have an array. You want to break that array into 2 arrays or 3 arrays. You can easily do it in NumPy using the array underscore split method. So here is the syntax of the method. You need to add 2 parameters. The first one would be obviously the array name you want to split, the array you want to split. And second would be the split number, that is the count of splits. So if you want to break an array into 2 parts, mention 2 here. If you want to break an array into 3 parts, mention 3 here. In this way, the array underscore split method works. We will see the following examples that will allow us to split a 1D as well as a 2D array. Okay, firstly, we will see how to split a 1D array. After splitting an array, we will see how we can access a split 1D array. So let's say you divided your 1D array into 2 parts. How you can access them individually, the 2 parts. Okay, we will understand it in the second example. The third example will cover the complete 2D array. That means how to split a 2D array and how to access each and every part of the 2D array after we break or slash it, that is split. So let's see the examples. So in the first example, we will split a one-dimensional array using the array underscore split method. We will split the array into 2 parts. So let's see. We have created a project on PyCharm for split. So let us create our first file. Right click, new Python file. Let me name it demo1. It will automatically add the .py extension because Python file is by default selected. Press enter. So it added demo1.py. Similarly, we can create 2 more files for our other examples quickly. So here it is. Let us see the first example, how we can split a one-dimensional array. For that, we will first import NumPy. Import NumPy as NP. NP is an alias. So let us create a 1D array n using NumPy, that is np.array, and within that create your 1D array, add elements for your array. Let's say I added the following elements, 6 elements. Now we will print the array. For a in n, that is for in loop, print a, split the array into two parts. How? Using the array underscore split method. Let us create a new array, resarr. This will show our output. So use NumPy, that is np.array underscore split, and within that mention the array name and comma. If you remember the syntax, the split number, that is the count of split. So we added it, and then print the array. Therefore it will now return two arrays because we broke it into two. Print the new array, that is resarr. This will show both our two arrays which we divided above. That's it. File, save all, right click and run demo1. That is, first we have displayed our array with 6 elements, then we have array count, split count as 2, and we have broken it into two parts. Okay, 10, 20, 30 and then 40, 50, 60. Okay, we did it using the array underscore split method, and here is the 2, the array count, the split count. So in this way guys, we can split a 1D array in NumPy using the array underscore split method. Now let us see another example in which we will access a split one-dimensional NumPy array. So let's say we want to individually access the split array. We have divided the array into two parts, but how we can access them individually? Okay, we can do that using the index number for the array element you want to display. So we have split our array into two parts. So how we can access the first part and second part individually, we will see in this example. Here it is, how we can access a 1D array that we have broken down. Import NumPy as np. After that, create an array. Okay, n is equal to np. We can take it from our previous example. That is, we created an array, we printed it. Okay, we created a one-dimensional array and added 6 elements. Then we iterated it. Now we will split into two. Split there into two. We will create a new array for the output, resarr. Now NumPy, that is np dot array underscore split method. Within that, first we will add the array, then we will add the count, that is the split count. We will divide into two. Okay, now after dividing into two, let's say we want to access the first part. How we can do that? For that, we will use the index number. Let me directly print it. So use the output array, and within that mention 0 for the first part after the two new arrays that we got from the following array, and similarly for the second one, type and index 1. Okay, in this way we can easily print array 1. We can write, that is a two array generated from our first array, from our initial array. So we have broken down into two paths. Okay, go to file, save all, right click and run demo. Here it is. This was our array. It was broken down into two by us, and one by one we have printed it. We could have also printed it initially, so that we know what we are doing. Array after splitting. Okay, right click, run demo 2. Now you can see iterating the array, then array after splitting. The following was our array. We broke it down into two. But what if you want to access only this one? For that, use the index number. So we used index 0 to print the first one, the first broken part, and index 1 to print the second broken part. So in this way, guys, we can easily access a split 1D array in NumPy. So guys, we saw using the index number, we can easily access a split 1D array. Now let us see how we can split a two-dimensional NumPy array and access it. We will see both of them in a single example. Okay, we will split the array into two parts and then we will display both of the parts individually. Third example. Here is our third example, how to split a 2D array in NumPy and access it individually. For that, import NumPy as NP. NP is our alias. Create a new array. We are creating n as a new array. Use NumPy, that is np.array method, and within that we will create our 2D array. So this is our 2 by 3 matrix, that is 2 row 3 column matrix. Okay, now we will print the array. Now we will print the array using for in loop. For a in n, print a. This will print our entire array one by one. Now we will split into two. We will split the array into two using let's say I'll create a new array for output, and then I'll use NumPy, that is np dot array underscore split method, and within that we will mention the array name which we want to break down, and now comma 2. So this will divide our complete array into two parts. If we'll add 3, it will divide into 3 parts. Now we will access also. Let us print the array completely. That's it. Now we will access it one by one individually. Okay, so this will be our array 1. We will be using the index number, that is RESARR, our output array. 0th index would be our first one. Let me fix this. And first index would be our second array which we have broken down. Okay, let's see the output file, save all. To understand the concept, right click, run demo 3. Now here it is, our 1D array, the following. Okay, after that we have printed the result here, but we wanted to access individually. So instead of working on this, we have displayed there individually. The first one is the following and the second one is here. So in this way, guys, we can easily split a 2D array and access each part individually. So guys, in this video we saw how we can easily split a NumPy array and how we can easily access individual values. Thank you for watching the video. In this video we will learn how we can search a NumPy array for a value. That is, we can search for a specific value in our array using the numpy.where method. We will see an example. So guys, we can easily search for a specific value using the where method. What will it return? It will return the index where the specific element is found. That is, let's say you are searching in a one-dimensional array, it will display you the exact index where the element is found. That's it. We will see an example to understand the concept. So we have created a project on PyCharm. Let us create a new file to run our program. Right click, new Python file. Name the file demo1.py. It will automatically add the .py extension after I'll press enter, because Python file is by default selected. Press enter. Here it is. Now let us run our first program. Let's begin. At first, we will import NumPy. We have also created an alias np. Now create a new array. N is equal to numpy, that is np dot array. Within that, add some values. Here it is. Now we can print the array. We will print it one by one using the for in loop. For a in n, that is the array name, print a. So this will display elements one by one, that is iteration, that is it will iterate. Now let us search for a specific value. Let's say I'll take a new variable res, and within that I'll use numpy, that is np.where method, and I'll add the conditions. So conditions you need to add here. Let's say I want to find the value 30 in our array. So I added the array name, that is n, and is equal to 30. That means I am finding 30 in my array. So 30 is here, index 2 and index 5. The same output will be visible. Element 30 found at the following indexes. Okay, that's it. Go to file, save all, right click, run demo1. So guys, here it is. Firstly, we iterated our array, okay, using the for in loop, and then we found the value using where method. So element 30 found at the following indexes 2 and 5. I told you 30 is visible at 0, 1, 2 and the fifth index. Okay, this is how the output gets printed, the exact indexes wherein the element is visible. So you need to add the boolean condition, the condition here. That's it. So guys, in this video we saw how we can search a NumPy array for a value using the where method. We just need to add the condition in it, and the output will display the exact indexes where the values are found. Thank you for watching the video. In this video we will learn how we can easily sort NumPy arrays. We will also see some examples. So a built-in function numpy.sort is used to sort arrays in a sequence. So to understand the concept, the sort function, what we will do, we will see 3 examples. First we will sort a 1D integer array, then we will sort a 1D string array, and then we will also see how to sort a 2-dimensional array. Let's begin. So at first we will see how to sort a 1-dimensional NumPy array, and that too an integer one. For that we will use the numpy.sort method as discussed before. Let us see the example. So here we have our PyCharm ID. We created a new project for sorting. So let us create our first Python file. To run our program, right click new, click on Python file. Now type the file name demo1, and when you will press enter, it will add a .py extension for Python because Python file is by default selected. So here it is, demo1.py created. In this way we can also create the other 2 programs for our 3 examples. So let us first see how to sort a 1-dimensional integer array in NumPy. So let us first import NumPy. We imported NumPy and also created an alias. Now let us create our first array n using numpy.array, that is np.array method. Add the elements for your 1D array, and that too unsorted one because we will sort it later. We have created our array. Let us print it, iterate it using for a in n before sorting, so that it's easier for us to understand. So I printed it. Now let us sort it using the sort method. We will sort it and directly print it. So this will be numpy, that is np.sort, and within that mention the array name. That's it. Here and we can also add a text, let's say sorted array. That's it. Go to file, save all, right click, run demo1. Here it is, guys. First we iterated the array. So this was our unsorted array. Then we sorted it completely using the numpy.sort method. So guys, in this way we can easily sort a 1D array using the sort method, and that too we sorted an integer array. Let's see the second example. So now we will sort a one-dimensional NumPy string array using the same sort method. Let's see. Let us sort a one-dimensional string array. First import NumPy and import NumPy as np. We have created an alias here, np. Now let us create a new array n and numpy.array method to create a 1D array. So herein we will add string elements. Let's say we added some technologies as our elements. You can add anything. Okay. Iterate the array. Let us print it using for in loop. For in n print a. Now we will sort it. Now we will sort it using the sort method. Okay, numpy, that is np.sort, in bracket mention n, that is the array, and here is the sorted array. You can mention sorted array. That's it. So this will sort our string array. File, save all, right click and run demo2. So at first we iterated our array one by one. Then we displayed the sorted array. Here it is, using the sort function. Here it is. So guys, this is how we can sort a one-dimensional string array. So we sorted the string array using the sort method in NumPy. Now for our last example, we will see how to sort a two-dimensional NumPy array using the sort function, the same function. Let's see. Sort a two-dimensional array in NumPy. For that, let us first import NumPy as np. Then create a new array. Let's say we created n and we added NumPy, that is np.array, and herein we will add our 2D array that is like a matrix. So I created it, and that too unsorted, 5 3 7 9, let's say 6. So this is an unsorted array, 2D array, 15 25 13 20. You can add any values. That's it. So we created a 2-row 5-column matrix, that is a 2D array in NumPy. Now let us also print it. For a in n colon print a. Now let us sort. Using NumPy, that is np.sort, and add the array name. That's it. Go to file, save all, right click and run demo3. Here we will see that first our 2 by 5 matrix, 2-row 5-column. Then we displayed a sorted matrix. So in this way, guys, you can easily sort a 2D array. So guys, in this video we saw how we can easily sort a one-dimensional and two-dimensional array in NumPy. Thank you for watching the video. In this video we will learn what are axes and how we can easily understand the concept of axes in NumPy. With that we will also see an example. Let's start. In NumPy the dimensions are called axes. The rows are considered along axis 0, that is vertical, whereas columns along axis 1, that is horizontal. Therefore, a two-dimensional NumPy array has the following axes. Let us see an example to understand the concept. So in this example, we'll be getting minimum value with axes. So we will use the axes attribute to set the axis value with 0 and 1, and we will print the minimum value from an array. Let's see the example. So we have our PyCharm ID here. We have created a project for our example. So I'll right click and click new and Python file to create our first file. We will name it as demo1 and I'll press enter. It will automatically add the extension because Python file is by default selected. Here it is, demo1.py. So specifying axis will calculate values along that specific axis only. Let's see the example. First we will import NumPy and add an alias. Now we will create a new array n numpy.array, that means np.array. Within that add your two-dimensional array. So first we added for the first row here, the complete one, and now for the second row. Then for the third row, iterate the array. Now use the for in loop to display. Iterate the array. Now we will get the minimum value. Using the min method. Now guys, we will get the minimum value with axis 0. With axis 0, that is vertical axis. Okay, here we have set the same min method, but for the axis we have set axis is equal to 0 for vertical axis. Get the minimum value. Okay, now for the horizontal axis I'll set 1. That's it. File, save all, right click and run. To understand the concept, run demo1. Okay, we did an error. One of the element is missing. It's fine now. Go to file, save all, right click and run demo1. Now here it is. Firstly, we printed our array. It is a 3-row 5-column matrix, 3x5 matrix. That is a two-dimensional array. Okay, we printed it first, so it is visible here. Then we have the minimum value. So the minimum value is 2 from the array, correct? So what will happen? We printed n.min and 2 is visible. Now we have printed minimum value with axis 0, that is vertical axis. So what it did, it actually printed the minimum value from each column, and in horizontal axis what will happen? It will display the minimum value from each row and display it, because we have said axis 1, that is horizontal axis, to 1500. That means 2 was the minimum from the first row, 15 was the minimum one from the second row, and 100 was the minimum from the third row. So the same got printed here to 1500 in an array form. So this is the purpose of working around axes in NumPy arrays. So in this video we saw what are axes in NumPy arrays and how we can work around them, how we can display the minimum value with axes. You can mention them axes or axes, AXIS or AXES in NumPy. But for them the attribute used would be axis, AXIS. Thank you for watching the video. In this lesson we will learn how to get the intersection of two arrays. For that we will use the intersect 1D method, and we will also work around some examples. At first we should know what is intersection. Intersection means finding common elements between two arrays. So you can easily do that using the intersect 1D method. We will see some examples. At first we will find the intersection between two arrays. Then we will follow a similar example to display that the output of intersection is a sorted array. Okay. And for the third example, what we will do, we will see what will happen if we'll try to find the intersection between two arrays with different elements. Since intersection finds common elements between arrays, we will see what will happen when both the arrays are having different elements. Let's begin. Here is the first example in which we will find the intersection of two arrays. That is the common elements between two arrays. So we'll be having two integer arrays and intersect 1D method will be used. So here's our PyCharm ID. We created a project for NumPy array. Let us add three files. Right click Python file. Now type demo1 and press enter. This will create a Python file, .py extension. Here it is. Similarly, let us create other two files. Now in the first example, we will find the intersection between two arrays. Let us create two arrays first. I'll import NumPy as NP. NP is an alias here. Now create two arrays. First one would be N1. So NumPy dot array. Add some elements. N2 is our second array. NP dot array. Let us add four elements. So here and 5 and 15 are similar elements in both the arrays. Now let us print the arrays. Iterating array 1. I'll use the for in loop for a in the first array and just print the value of a. This will print our array. Colon you need to add. Let us do the same for the second array. Now we will find the intersection. For that we will take a new array object. That will be our output array. Use NumPy dot intersect 1D method. And within that just add both the array names N1 and N2. That's it. And we just need to print the value of the output array. That's it. And herein mention intersection. And herein mention intersection. That's it. This is fine now. Okay, now go to file, save all, right click, run demo1. Herein we are having our first array, then we are having our second array. And the result of the intersection is an array with common elements, that is 5 and 15 from both the arrays. Okay. Now let us see the second example in which we'll be using the same intersect 1D method on two integer arrays. and it will display a sorted result. Okay, so this is what happens in intersection. It first finds the common elements and the resultant array will be sorted. Here it is, import numpy as np. Let us create two arrays, n1, numpy.array, add some values. Let's say we will now add unsorted values. Do the same for the second array, n2, numpy.array. We are adding unsorted values here also to display you that the output will be a sorted array. Now print. So here we are iterating array 1, that is printing array 1 using for in loop. For a in the first array, print the value of a to print the array. Now do the same for the second array, 2 and the value of the second array. That's it. Now find the intersection. Use a new array, RESARR. This is our new array object that would be having the sorted array result, intersection result. numpy.intersect 1D. In the brackets add both the arrays and just print those arrays. This will be the output, a sorted output. Okay, we'll write the same and that's it. Just mention RESARR. Now go to file, save all, right click and run. Let's see. Herein we are having our both the arrays. Okay. We are iterating the second array and the sorted result is an output in sorted form. Okay, we can just change it. Let's say I'll add 100 here and I'll run it again. And now three values will be same. Here it is 100. But the thing you need to notice is the result is sorted even when both the arrays were unsorted. So this is what we wanted to show in our second example. Now let us move to the third example. In the third example, we will find the intersection between two arrays with different elements. Now let's say what will happen. Since intersection finds common elements, what will happen if both the arrays are having different elements? That is not even a single element same. Here it is. Now let us import NumPy. We added an alias np. Now let us create two arrays. n1 is equal to np.array. n2 is equal to np.array. This is the second array. Both the arrays are having different elements, you can check. And now we will print the arrays. We are iterating the first array, that is printing the first array. Now we will use the for loop and display our first array. Similarly, using the for in loop, the same for loop will be displaying the second array. Okay, now what we need to do, we will find the intersection of both the arrays using a new array, resultant array RESARR, new array object, numpy.intersect 1D and add the n1 n2 values. That's it. Now print. Now we will be displaying the intersection. Now we will be displaying the intersection of different elements in both the arrays, let's say. Since both the arrays are having different elements, so it will display an empty array. Right click, You can file save all, you can save it, right click, run demo 3. Now you can see both the elements are visible with different elements. Both the arrays are having different elements. Okay, the output will be an empty array. That's it. This is what we wanted to show. Okay, so guys, in this video we saw how we can easily find the intersection of NumPy arrays. Thank you for watching the video. In this video we will learn how we can easily find the difference between NumPy arrays. With that, we will also see some examples. Let us first understand what is the meaning of finding the difference between two NumPy arrays. That would mean, let's say you are subtracting two arrays, the first and the second array. That will subtract the common elements from the first array, and rest of the elements from the first array will get displayed. We have this setDiff1d method that will find a difference between two arrays. Okay, so this is the syntax. The first and second arrays are placed as two parameter values for the numpy.setDiff1d method. Here it is, the first array as well as the second array. So when we'll perform this, it will subtract the common elements from the first array in comparison with the second array, and the rest of the remaining values which are not common from array 1 will get displayed. Now let's see two examples to understand the concept. In the first example, we will find a difference between two arrays using the numpy.setDiff1d method. Let's go to PyCharm. Herein we have created a project. Let us create a file. Right click, new, Python file, type demo1, press enter. It will automatically create .py file because Python file is by default selected. Here it is, our first file. Let us create the second file also, since we are having two examples. Now we are having demo2 also. Let us find the difference. So we will simply find the difference between two arrays. Let us import NumPy as NP. That is, NP is our alias here for the NumPy library. Now create first array, that is n1 NumPy array object. Use NumPy, that is np.array method, and within this add the array values. Let's say array elements, I'm adding it here. So I have added 10 elements. Now create a new array. Since we want to find the difference between two arrays, numpy.array. Now I'll add values. So we added 10 values here also. Now you can see the difference between two arrays. Let us print both the arrays. Now use the for loop for a in the first array and print the value of a to display the array. Iterate the array. Do the same for the second array. N2, that is the second array. Now let us find the difference. Use a new array diff arr, let's say numpy.set diff 1d, and within that add both the arrays to find the difference and print the result, the difference between both the arrays. That's it. So here you can see, I told you before, if we are subtracting two arrays n1 and n2, this will subtract the common elements from the n1. So what are the common elements between both these will get subtracted from the first array. Here you can see 30, 35, 50. These three are the common elements, 30, 35 and 50. Rest will get displayed. That means 40, 45 will also get displayed, 25, 20, 15, 10, 5 will also get displayed. Let's see. 5, save all, right click and run. Run demo 1. So here is our first array and here is our second array. The result difference is the following. I told you 40, 45, 25, 20, 15, 10, 5 will get displayed. That is the remaining array, the remaining first array N1 after deducting the similar values. So in this way we can work around the difference between NumPy arrays. Now let us see the second example. What we'll do, we will just swap the parameters and perform n2 minus n1. That is the second array. That is second array minus the first array. Here it is n2 minus n1. Let's see. So herein we have our example n2 minus n1 we will perform. Let us add both the arrays and also print them. So we can just take this from here and here it is, same array. Okay, now what we'll do, we will just perform n2 minus n1 instead of n1 minus n2 here. That's it, simple. So let's say I took diff ARR numpy dot set diff 1d n2 minus n1, that's it, and print the values, print the difference. And print the difference. Okay, now what will happen, n2 minus n1, the concept will get reversed because we reverse the parameters. Now set diff 1d will subtract the common elements from the n2 array, okay, and display the rest of the elements from the n2 array. 30, 35 and 50 are similar, so from the n2 array rest of the elements will get displayed. That means 55, 60, 65, 75, 85, 95 and 100 should be the output. File, save all, right click and run demo 2. Okay, there's a mistake I guess. Okay, here it is, n2 minus n1. Yes, file, save all, right click and run demo 2. Here it is, I told you the following will get displayed. Okay, the remaining elements from the n2 array, this array. So guys, this is how you can work around finding difference between two arrays in NumPy. Thank you for watching the video. In this video we will learn how we can easily perform arithmetic operations on NumPy arrays. So we'll be performing the operations using the sum, subtract, multiply and divide methods that will allow us to add, subtract, multiply and divide NumPy arrays respectively. So at first let us begin with adding NumPy arrays. For that we have the sum method. It will add each and every element of both the arrays, but the result will be displayed in a new array. Okay, so these are the examples. We will first add all the elements, then we will add only the column values of both the arrays, then we will add individual array values using the axis parameter that will allow you to differentiate between row and column values. So here is a PyCharm ID. What we'll do, right click new, create a new Python file, click on it, Python file. I'll type demo1 and press enter. It will automatically add the extension.py because Python file is by default selected. Here it is, our first file. We have 3 examples, so I'll create 3 files quickly. Here it is guys, we have created 3 files for the 3 examples. Let us begin with the first example to add the elements of NumPy arrays. First import the NumPy library, import NumPy as np. np is our alias here. Let us create 2 arrays. n1 is equal to numpy.array. We have created it. Now the second array, numpy.array, numpy.array, are arrays which will add. Okay, we can print them. The first array, the second array. Okay, now let us create a new array, output array, to display the output. Use numpy.sum method and add both the arrays in it as parameters, n1 comma n2. That's it, nothing else. Just print it. Sum you can mention and just print RESARR, the output. That's it, nothing else. File, save all, right click, run demo 1. Okay, I guess syntax error. Yes, that's fine now. File, save all, file, save all, right click, run demo 1, and here it is. It added all the elements and added both the arrays. Sum is 410. Now move to the second example in which we will add only the column values. Okay, for that let us get the files, both the arrays from here. Okay, we have two arrays here and we will just only add the column values. Let's see what does that mean. For that we'll be using the access parameter. This is the output array, numpy.sum. Within that add both our arrays n1 and n2 and use the access parameter and set it to 0. Adding it to 0, what will happen? It will only add the column values. Let us print the output. Okay, I'll just go to file and save all and right click, run demo 2. Herein you can see it only added the column values. How? First column of the first array is 15 and first column of the second array is 65. Adding it is 80. Same for 20 plus 75, 95. 25 plus 85, 110. And 30 plus 95, 125. So it added only the column values using the axis is equal to 0 parameter. Axis is equal to 0 parameter. That's it. Now let us move to the third example in which individual array values will get printed. Okay, that means the row values also. So what I'll do, I'll again copy this. Okay, now I'll just use the output array RESARR is equal to numpy.sum n1 comma n2, that is both the objects, and comma x is equal to 1. We added 0 before, now it's 1. Okay, so this will add row values, individual row values. Okay, let us print the sum. That is the output, and we have x is equal to 1. Go to file, save all, right click, run demo 3. It added the individual array values because we added x is equal to 1. 15 plus 20 plus 25 plus 30 is equal to 90, and 65 plus 75 plus 85 plus 95 is equal to plus 95 is equal to 320, and it added both of them to a new array. So in this way guys, we can work around adding array values. So guys, we saw how we can add NumPy arrays using the sum method with 3 examples. Now we will learn how to subtract NumPy arrays using the subtract method. It will allow you to subtract one array from another and the output will be displayed in a new array. So let's see an example. So we will see how to subtract NumPy arrays using the subtract method. Import NumPy, the library as np is our alias. Now let us create two arrays. n1 is equal to numpy.array, and within that add values. Now the second array, add some values. That's it. Print both the arrays. Here it is. We printed the first array and the second array now. Now guys, we will subtract and display in a new array. So we will display the result here. A new array object numpy.subtract to subtract the numpy array values, and within that add n1 comma n2, that is both the arrays we want to subtract. Print subtraction result RESARR. That's it. Now let us see what will happen. Go to file, save all, right click, run demo 4. Herein you can see it subtracted the values. 15 minus 65 is equal to minus 50, 20 minus 75 is equal to minus 55, 25 minus 85 is equal to minus 60, and 30 minus 95 is equal to minus 65. So this is the subtraction result. So this is how you can find the subtraction between two arrays using the subtract method. So guys, we saw how to find the subtraction between two arrays, how to subtract two arrays. Now we will learn how to multiply two arrays in NumPy. For that we'll be using the multiply method, and the result of the multiplication will be displayed in a new array. Let us see the example. Let us see now how to multiply NumPy arrays using the multiply method. Import NumPy as NP. We are importing our library and using NP as an alias. For the first array, we will create the first array n1 and use numpy.array method. Added 4 values. Now our second array numpy.array. Now let us print both the arrays. Now the second array, we have printed both the arrays. We will just multiply. Okay. Take a new array. The result will be displayed here. RESARR, new array object, numpy dot multiply method to multiply both the arrays. That's it. Add n1 comma n2 and print the result. That is RESARR. File, save all, right click, run demo 5. Here are both the arrays and we multiplied them. What will happen? 15 will be multiplied by 65, and here is the result. 20 by 75, 1500 is the result. 25 by 85, 2125, and 30 by 95, 2850 result. So we multiplied both the arrays. In this way guys, we can easily multiply arrays using the multiply method. So we multiplied two NumPy arrays using the multiply method. Let us see our last example. Now we will see how to divide NumPy arrays using the divide method. This will divide the elements of one array with elements of another, and the result will be displayed in a new array. Let's see an example. Now we will learn how to divide NumPy arrays. Let us import the NumPy library, import NumPy as NP. Create two arrays. The second array numpy.array. Add values. That's it. Print the array. We printed both the arrays now. Now let us create a new array object to display the output here. Output will get displayed in the following: RESARR numpy.divide. method to divide both the arrays, elements of both the arrays, n2 comma n1. So this will be like n2 divided by n1. Print the output, division result. File, save all, right click and run to understand the concept. Run demo 6. So what it did, it actually performed n2 divided by n1, that is like n2 divided by n1. It performed like this. Okay, so 65 divided by 15 is 4.3, 75 divided by 20 is 3.75, 85 divided by 25 is 3.4, and 95 divided by 30 is 3.16. So in this way guys, we can work around divide method. So guys, we divided both the arrays using the divide method. In this video we saw how we can easily work around arithmetic operations on NumPy arrays. We saw how to add, subtract, multiply and divide NumPy arrays. Thank you for watching the video. In this video we will learn how to perform scalar operations on NumPy arrays. We will understand the concept with some examples. So scalar operations are basically operations that include performing addition, subtraction, multiplication and division on each and every element of a NumPy array. So this is what we call a scalar operation, to perform on each element of an array in NumPy. Okay, so herein we will see some examples that include addition, subtraction, multiplication and division operations. Let's start. The first one would be addition operation. So we'll be adding a particular value to each element of a NumPy array. Let's see. So this is our PyCharm ID. We have created a new project. Let us create a new file for our example. Right click, new Python file. Name the file. I'll name it demo1. I'll press enter and it will automatically add the .py extension because Python file is by default selected. Here it is. So we are having 3 more examples. So let me create 3 more files. So here it is. Let us first perform addition operation on NumPy arrays. Addition scalar operation. Okay, that means adding a value to each element of a NumPy array. For that, let me import NumPy and add an alias. Let us create 2 arrays. N1 is our array, np.array, that is numpy.array method, and add the elements of the array now. Okay, do the same for the second array, n2, np.array, 65, 75, you can add any value, 75, 85, 95. That's it. Now print the first array easily, n1. Now the second array. Now we will perform addition on the first array, that is add any value, that is, let's say I'll add 10 to the first array and 20 to the second array. That's it. Now print both the arrays. Now both the arrays will get updated. File, save all, right click, run demo1. Now let's see the output. Here it is. This is array 1 and the following is array 2. We added 10 to array 1. Here it is. 10 value to each and every element of the first array, that is 15 plus 10 25, 20 plus 10 30, 25 plus 10 35 and 30 plus 10 40. We did the same for the second array. We added 20 to each element, that is 65 plus 20 85, 75 plus 20 95, 85 plus 20 105 and 95 plus 20 115. So this is how you can perform scalar operations on a NumPy array, and that too the addition operation. So we performed the addition operation and added a particular value to each and every element of an array. Now we will see how we can perform subtraction operation, that is a scalar operation for subtraction. Okay, this will subtract a value, a specific value from each and every element of an array. Let's see. Import NumPy as np as an alias, np as an alias. Let us add two elements using numpy.array. Add the elements for both the arrays n1 and n2. We can take from here, and I'll also display it. Okay, so we have our array with 4 elements n1 and n2 with 4 elements. We have printed both the arrays. Now let's say I'll just subtract a value, a specific value from the NumPy array. n1 is equal to n1 minus 5. Minus 5 will get deleted from each and every element of the first array, and n2 minus 10. 10 will get deleted from each and every value of the second array. Now let us print. Okay, now what we will do, file, save all, right click and run. So what we did, these were our arrays. We deleted a specific value from each and every element. That is, we deleted 5 from each and every element of the first array. That is 15 minus 5, 10, 20 minus 5, 15, 25 minus 5, 20, 30 minus 5, 25, and we did the same for the second array. That is the following. We deleted 10. 65 minus 10, 55, 75 minus 10, 65, 85 minus 10, 75, and 95 minus 10, 85. So this is how we can perform scalar operations on a NumPy array to subtract specific value from all the array elements one by one. So guys, we use the subtraction operation to subtract a specific value from each element. Now let us see the multiplication operation, in which we will perform scalar operations on a NumPy array to multiply a specific value to each element. Let's see. Let us perform the multiplication operation on each element of a NumPy array. Import NumPy as np. Let's see the first element, or we can take it from here. Here are both the arrays, 4 elements each, and we printed them. Now let us perform the multiplication scalar operation. n1 is equal to n1 into 5, so each element will get multiplied by 5. And for the second array, each element, let's say, will get multiplied by 10 for our example. Since we have updated the array, we will print it. Do the same for second array. That's it, we have updated them. File, save all, right click and run demo 3. So here are both the arrays. Now multiply each value by 5 for the first array. 15 into 5, 75, 20 into 5, 100, 25 into 5, 125, and 30 into 5, 150. So it's fine. And multiply each value of the second array by 10. 65 into 10, 650, 75 into 10, 750, 85 into 10, 850, and 95 into 10, 950. So this is how we can work around the scalar multiplication operation in NumPy. So we worked around the multiplication operation and multiplied each value of a NumPy, each element of a NumPy array by a specific value. Now we will see the division operation. This will divide a value from each element of a NumPy array, a specific value. Let's see the division operation. Import NumPy as np and create a new array, 2 new arrays. Similarly, Okay, we have two arrays and we will perform division operation. We printed both the arrays. Now let us perform a scalar operation on the first array, n1 divided by 5, and let's say n2 divided by 5, and that's it. We will print the updated arrays. This is array 2. Right click and run demo 4. Let's see what will happen. So we divided the first array by 5. So 15 divided by 5 3, 20 divided by 5 4, 25 divided by 5 5, and 30 divided by 5 6. Did the same for the second array. We divided each element by 5. 65 divided by 5 13, 75 divided by 5 15, 85 divided by 5 17, 95 divided by 5 19. So this is how, guys, we can perform the multiplication operation on NumPy arrays. So this is how we perform the division operation on each and every element of a NumPy array. So guys, in this video we saw how we can perform scalar operations on NumPy array, that is on each and every value of a NumPy array. In this video we will learn how we can work around the statistical operations on NumPy arrays. We will also see some examples. So the statistical operations mainly include mean, median and standard deviation, and we will work around all three of them. Mean is the average of the given values, median is the middle value of the given values, and standard deviation is basically a measure of the amount of variation or dispersion of the given values. In this case, the given values are array elements. Okay, NumPy array elements. Let us begin with the first operation, mean. So mean is the average of the given values. If you have 5 elements, the mean would be the average of those 5 elements. Okay, so in this case these elements are array elements, and we'll be using the mean method to perform the mean statistical operation on a NumPy array. Let's see. So here we have created a project on PyCharm. So let us create our first file. Right click, new, Python file, give the name demo1, press enter, and on pressing enter it will add an extension .py since Python file is by default selected. Here it is, our first example. Let us create 2 more files for our other examples. Let us find the mean. At first we will import NumPy library and create an alias also. Now let us create 2 arrays so that we can show 2 examples. n1 is equal to numpy.array, that is np.array. Within that add elements. Let's say we added 4 elements, and create a second array, numpy.array. Do the same for both of them, that is add 4 elements here also, or you can add any number of elements. Now let us print the array using the print command. Print the second array also. Now let us find the mean. For that I'll take we are taking res mean1 variable. Within that use numpy.mean method and add the array for which you want to find the mean. Okay, do the same for the second also. Here I'll change the name of the variable n2. That's it. Now print the mean values. Array1 mean. Okay, and array2 mean. That's it. File, save all, right click and run demo1. Here it is. So what I can do, I can remove this. That's it. Right click, run demo 1. Now this looks fine. So the average of the first array is 22.5, whereas for the second array it's the following array is it's 80. So this is how we can find the mean, that is the average. So we found the mean of the given values, that is the average of the given values, using the mean method in NumPy. Now we will find the median of the array values, that is median is used to find the middle value of the given values using the median method. Let's see an example. Here it is. Let us see an example. Import NumPy as NP. Now let us create two arrays. We can take from here and print them. We are showing two examples here using two arrays, n1 and n2. Both are having 4 elements. You can add any number of elements. We have printed both the arrays. Now I'll find the median. Let us take a variable. Okay, this is where we will display the output. Use numpy.median method, that's it, and add the array. Similarly do for the second array 2, and we created a new one. We found the median of the second array also by passing it as a parameter for the median method. Now print the result. Array 1 median. Okay, and array 2 median. That's it, we printed both of them. Now go to file, save all, right click and run demo 2. Here it is, both the arrays and the median. So this is how we found the median of the array elements, that is the middle value of the given values. Okay, that is the middle value of the given values, 22.5, and 80 is the middle value for the second array, and the same is visible. In this way guys, we can easily find the middle value using the median method in NumPy. Now let us work around standard deviation. Standard deviation is basically a measure of the amount of variation of the given values, that is the given array values. We can find the standard deviation using the std method. Let's see an example. Here we'll find the standard deviation. Import NumPy as np. Create two arrays, and we will try to find the standard deviation. Let me take it from here. Okay, we have two arrays now with 4 elements each, and we printed both of them. Now we need to find the standard deviation. This is where our output will get saved. Use numpy.std, that is standard deviation for the first array. And do the same for the second array. That's it. Print both the outputs. Okay. Array 1 standard deviation. Okay, and the same for second one. That's it. We found the standard deviation. Go to file, save all, right click and run demo 3. Here it is. So these were our arrays. This is the standard deviation of both the arrays, that is array values. So this is how we can find the standard deviation using the std method. In this video we saw how we can work around the statistical operations on a NumPy array. We found the mean, median as well as standard deviation. In this video we will learn what is a random module in NumPy. We will also see some examples. So if you want to work with random numbers, NumPy has a module called random. Let's see. To import this module, first we need to install NumPy, obviously, because it is a NumPy module. After installing NumPy, you need to just import random like this from NumPy import random. That is, we are actually importing random from NumPy library because it is a part of it. So in this video, we will see the following examples. First, we will generate a random number. Then we will generate a random array with a fixed size. And in the end, we will generate one of the random values based on an array of values. Let's begin. So first we will generate a random number, okay, using the rand int method of the random module. So let us see an example. Here we have our PyCharm ID. We have created a new project for random module. Let us create a new Python file. Right click new, click on Python file, type the name of the file. Since Python file is by default selected, it will automatically add the .py Python extension. Press enter. Here it is. It has added the Python extension. Since we have two more examples, I'll create two more files quickly. So we have created two more files. Let us see the first example. In this example, we will generate a random number in NumPy. Since we already installed the NumPy library, the NumPy package in PyCharm ID, what we need to do to work around random, type from NumPy and import random. That's it. This will allow you to work on the random module. Now let us get the random number. Take a variable, type random, that is a random module, and use the rand int method. Within that, add 5. So this will generate random values from 0 to 5. Okay. Get random values or random number from 0 to 5 because we have added 5. If we added 10, it would have displayed from 0 to 10. Okay, but I'll go for 5. Now that's it. Just print the random number. That's it. N. Now go to file, save all, right click, run demo 1. So we have printed the random number. It generated 1. When I'll run it again, right click run, a different random number will get displayed. 0, it's visible. So from 0 to 5, it will be visible. A random number will be visible because we have set 5 here. So guys, in this way we can easily generate a random number using the rand int method. Now let us see how we can generate a random number with a fixed size. So we will generate random elements of an array using the random.randint method. That is the randint method of the random module. Okay. Since we're talking about array, so how the fixed size will be set? It will be set using the size parameter. So let us see the example. Type from NumPy. Since we already have NumPy in PyCharm, we installed it. So just type from NumPy, import random to work around the random module. Now we will create a variable n and use the random module dot randint method. Within that 10. So in the previous example, we have done the same. But here what we need to do, we need to also set the size. I'll set the size using the size parameter. So what will happen? From 0 to 10, it will display random numbers, and total random numbers it will display will be 3 and in an array form. Okay. We can write here. So we can write here get 3 random numbers as array elements because an array will be displayed as an output. From 0 to 10. Why? Because we have set 10 here. Just like in the previous example, we have set 5. So from 0 to 5, we generated a random number. Here we are just generating it in an array with a size we set on our own using the size parameter. That's it. Print. That's it. Go to file, save all, right click, run demo 2. Now here you can see it generated 3 random values from 0 to 10. since we have set 10 here. When I'll run it again, run demo 2, different values will be visible. 164 are visible. So this is how we can work around finding random values and generating the result in an array. So we generated random elements of an array using the randint method. So in this example, what we'll do, we will generate one of the random values based on an array of values using the choice method of the random module. Okay. Let us understand the concept using an example. At first, import random. Since we installed NumPy before, just write from NumPy import random. So we have imported it in our program. Now take a new variable n, use random module dot choice, and within this we will set the values in an array, and from those values only the random number will get generated. Let's say I'll add 10 values, and since we have used the choice method, one of these values, random values, will get displayed. Go to File, Save All, right click, Run Demo 3. You can see 20 gets generated because it is a part of this array, and the same got displayed. When I'll right click and run again, any other value from this list will get displayed as a random number. So this is the purpose of the choice method. 70 is visible here. I'll do it again and some other value will get displayed, 30. So in this way, guys, we can set our own values to be displayed as a random value, individual value. We achieved the same using the choice method of the random module. In this video, we saw how we can work around the random module in NumPy. We saw 3 examples, and we also saw how we can import it in NumPy. Thank you for watching the video. In this video, we will learn how we can easily work on logs with NumPy. So Python NumPy has some predefined functions to work with logs. Let us see them. These will allow you to find the value of log, like log base 2, log base 10, and others. So in this lesson, we will work around 2 examples, log base 2 and log base 10, and how we can easily find them with NumPy. Now what will be the input to both these functions? That will be a NumPy array. Let's see an example. So we'll be finding log base 2. For that, we'll be using the numpy.log2 method. So here is our PyCharm ID. We have created a project. Let us create our first file to find log base 2. Right click, new Python file. Name it, I'll give it demo1 and I'll press enter. It will add a Python extension because Python file is by default selected. Here it is, demo1. Let us create demo2 also for a second example. Press enter. So guys, now we have both our files. First we will find log base 2. So let us find log base 2 first. For that, first import NumPy and create an alias, import. Now we will create a NumPy array with some elements. N is equal to NumPy dot, that is np dot array. Within that, add the values for which you want the log base 2, that is log2 1, log2 2, log2 3, log2 4 and log2 5. So for each array element, log2 will be displayed. Let us print the array also. Now we will find log base 2. Type the print command. Result numpy.log2, and we have added the array in it. So log2 for all these values will be evaluated. File, save all, right click and run. Run demo1. Here it is, guys. This is our array and this is the value of log base 2 for all these values. Okay. In this way we can find log base 2. Now guys, we will see how to find log base 10 using the numpy.log10 method. We will find the log base 10. Let's see an example. So let's find log base 10. Import numpy as np. Now we will create an array n numpy.array. Within that add the values. Let's say we added some random values and we printed the array. Now let us find log 10 numpy.log10 bracket n is the array, and for all these values we'll be able to find log base 10. That's it, nothing else. Go to file, save all, right click and run demo 2. Here is the output. So this is our array and this is log base 10 for all these values individually. So in this way guys, we can find log base 10. So guys, in this video we saw how we can work around NumPy logs and use some predefined functions to find log 2 and log 10. Thank you for watching the video. In this video we will learn how we can find the LCM and HCF of two numbers in NumPy. With that we will also see some examples. So to find the HCM and LCM of two numbers, we use the LCM method as well as the GCD method respectively. Okay, HCF is also known as GCD. So let us see them one by one and run their examples also using these methods. First would be how to find the LCM of two numbers. Now what is LCM? LCM is the least common multiple of two numbers. Okay, for that NumPy is having a predefined function, or you can say a built-in function known as LCM, which is also called least common multiple because you are finding the least common multiple of two numbers. That is the least number that divides both the numbers. Let's see an example. So here we have created a new project in PyCharm. Let us create a new Python file to run our program. Right click, new Python file, type demo1 and press enter. This will add an extension .py because Python file is by default selected. Now here we have our first program, demo1.py. Let us create another program because we will be showing two examples. That is for LCM and HCF. Right click, new Python file, demo2, press enter. So we have our two files. Here we will run our LCM example. So here it is, find LCM of two numbers. What we will do? First we will import NumPy as np, and herein NumPy is our library and np is an alias. Now guys, we will add two numbers. Let's say the numbers are A3 and B12. Now we are finding the LCM of it. That is the least common multiple. For that guys, let us take a variable and within that we will find the LCM. So type np, that is numpy dot the LCM method. I told you we'll be using the LCM method. Sorry, yeah, that's fine. Numpy dot LCM, and in the brackets we'll be adding both the numbers. That's it. So this is the syntax. Just add both the numbers. Just add the numbers you want to find the LCM. Here in A and B, 3 and 12. Now we will print the output. That is, we'll print res, the result of the following. Go to file, save all, right click, run demo1. So here you can see the least common multiple, the LCM of 3 and 12 is 12 here, and we have used the LCM method for it. So guys, we found the LCM of two numbers using the LCM method. Now we will see how we can find the HCF of two numbers. HCF is also known as GCD. So the GCD of two numbers is actually the greatest number that divides both the integers. Okay. For that we have the GCD method in NumPy. Herein we also call GCD as HCF, that is GCD is greatest common divisor, and it can also be called as HCF, that is highest common factor. Let us see an example. Okay, find GCD or HCF of two numbers. At first we will import NumPy, our library, and add an alias for it. Now what I'll do, I'll just add two numbers for which I want to find the HCF or GCD. A is equal to 2, B is equal to 8. Then I'll take a new variable, let's say res, that is result, and I'll be using numpy.gcd method to find the greatest common divisor, that is HCF. In the bracket just add both the numbers for which you want to find the greatest common divisor, that is A and B. This is the syntax of GCD. Just add the numbers in between for which you want to find the GCD or HCF. Now we will just print the output. GCD of two numbers. Okay, res, that's it. We have displayed the result, that is the following, and it will display the GCD. File, save all, right click and run demo 2. Here you can see the GCD, that is the greatest common divisor of 2 and 8 is 2. Okay, that is the greatest number that divides both the integers is 2. Guys, we saw how we can find the HCF or GCD of two numbers. In this video, we saw how we can find the LCM as well as the GCD or HCF of two numbers in NumPy using the predefined built-in methods. Thank you for watching the video.